Hello everyone, welcome to Algebra 1 class. This is Mom Joy and I'm here to help you out in your next math journey. And now we're moving on to Chapter 2, Linear Equations and Inequalities. This video will help you learn Number 1, to simplify expressions by combining similar terms. Number 2, simplify expressions by applying the distributive property and then combining similar terms. And number 3, calculate the value of an expression for a given value of a variable. Before we begin with our main lesson, here's a quick brain exercise. I want you to read with me this problem and then analyze and carefully plan your solution. And when you're ready, you can leave your answer as comments below. Now, are you ready to read with me the problem? Okay, go. If a cellular company charges 1,000 baht per month plus 7.50 baht for each minute, or a fraction of a minute, t, that you use one of their cellular phones, then the amount of your monthly bill is given by the expression 1,000 plus 7.50 t. Let's say you use the phone for 30 minutes in 1 month. How much will you pay for the company? So you may pause the video to solve the problem. Moving on. Now, we deal with algebraic expressions. What is an algebraic expression? It is a collection of real numbers, variables, grouping symbols, and operation symbols. Here are some examples. 5x squared plus x minus 7, 4, 1/3 xy minus 5 over 7, and negative 7 quantity x minus 2. The given expressions, you see numbers, variables, operations, as well as grouping symbols. Aside from that, what have you noticed? Aren't you seeing different kinds of combinations of numbers and variables? And how are they being separated? You see the addition and the subtraction signs, right? So to fully understand them, let's take a closer look at the different terms involved. Consider the example 5x squared plus x minus 7. This expression has 3 terms, 5x squared, x, and negative 7. How do we know? They are being separated by the operations addition and subtraction. Now, the number in front of the variable is called the coefficient. Most of the time, they are real numbers. They are factors. Okay? Now, the first term here has a coefficient 5. The second term, you don't see any number, so it means there is a 1 in front of x, okay? And negative 7 doesn't have a coefficient because you don't see any variables attached to it. Hence, this number, if it stands alone, is called a constant, okay? So a constant is a term with no variable attached to it. Have you heard about similar or like terms? Well, they are very important when it comes to simplifying expressions. Why? Because we can only combine like terms or similar terms. Okay? Take a look at these given examples. That will give us a hint that we can only add or subtract if they are like terms. Okay, no matter what is their coefficient, as long as the variables are exactly the same, so we can proceed with addition and subtraction. How do we add or subtract? We simply looked at the coefficients. So for example, for letter A, we have 1A. You don't see a number in front, it means a 1. So we have 1A plus 1A plus 1A plus 1A plus 1A. So since they're all A's, we can combine them. So 1 plus 1 plus 1 plus 1 plus 1. This will give us 5A. For K, we have 4K plus 5K minus 2K. So we simply add the coefficients. 4 plus 5 is 9, minus 2 is 7K. Therefore, the whole thing is 7K. Get it? Okay, great. More examples. This time, you notice two variables involved and others have exponents other than 1. So the same principle will be applied. As long as the variables are identical, meaning exactly the same, then we can proceed with addition and subtraction. However, if the coefficients or the variables are not exactly the same or they are not identical, then we cannot combine the terms. So instead, we just leave them like that. Okay, take a look at this example. 4x plus 7y minus x plus 5y. And so you can see that we can go ahead and combine like terms. So we can actually rewrite them in order to avoid confusions. So let's start with the 4x minus x plus 7y plus 5y. And then we proceed with addition and subtraction. 4x minus x is 3x, and 7y plus 5y is 12. Now you see, the first term has a variable x, the second term has a variable y. Therefore, we cannot combine them anymore, and we stopped. Therefore, the simplified form of 4x plus 7y minus x plus 5y is equals to 3x plus 12y. Okay, now let's try this one. It looks long, but it's not that hard. So first, we will organize the terms by combining like terms. So let's start with x and with the highest degree. So let's write 4x squared plus 12x squared, and then 4x will follow, minus 3x. Okay, we're going to write minus 13y now, and finally plus 3. So we have 1, 2, 3, 4, 5, 6 terms. At the bottom we have 1, 2, 3, 4, 5, 6 terms. So just make sure that we don't miss anything. Now let's combine like terms. So 4 plus 12 is 16, and copy x squared. 4 minus 3 is 1, so that's positive 1x or x. And then since negative 13y and plus 3 aren't like terms, so we just need to copy them. Okay, one more time. This is an x squared, this is an x, so we cannot combine them. Leave it like that. This is a y and a coefficient. So now this is the final simplified form of this expression. And of course, we cannot deny the fact that we still need those properties that we have learned earlier. And so this time we're going to use distributive properties, since we're going to see parentheses or grouping symbols. Okay, so we all know distributive property. So let's go ahead with the definition one more time. Okay, now you remember that we have to distribute whatever is on the left side, whatever is outside the parentheses, putting that into application. So if you have 5 and 7 as the terms inside the parentheses, we have to multiply it with the x outside. So 5x plus 7x, since they're both like terms, therefore we can say that 5x plus 7x finally is 12x. One more example. Let's say we have a negative coefficient. Okay, no matter what is that number outside, we just need to go ahead and do distributive property. So we're going to distribute negative 6 to the inside term. So let's go ahead. Negative 6 times x is negative 6x, and negative 6 times 2, it's a negative times positive, so it's a negative 12. Can we combine? No, they're unlike terms, so we'll leave it like that. Now let's simplify expressions with parentheses. Okay, so we still follow the distributive property, no matter how it looks like. Okay, so let's apply distributive property. So distribute 5 to x and negative 2. So that will give us 5x. 5 times negative 2 is negative 10. Negative 3 times 2x is minus 6x. Negative 3 times negative 7 is positive 21. Now we can combine terms. 5 minus 6 is negative 1 or negative x. Negative 10 plus 21 is the same as 21 minus 10. That will give us positive 11. And there you go. Final answer. Now, if it happens that you're asked to simplify terms inside a parenthesis without any number outside, then it's understood that everything is multiplied to 1. So therefore, we can go ahead and simplify. So 1 times x is just an x, and 1 times negative 2 is minus 2. So with or without parentheses, these two values are equivalent. Okay, next, we have a negative outside. What does it mean? Okay, if you don't see a number, it means a 1. Therefore, we multiply negative 1 to the inside terms. So negative 1, let me write negative 1 times 4x, negative 1 times a negative 3. So this will give us a negative 4x. Negative times negative is positive 3. There you go. How about if the coefficient is a fraction? Nothing much big difference. You just go ahead and multiply them. Okay, so 1/2 multiplied to 6x. So that's 1/2 times 6x. And then multiply 1/2 to 10 plus 1/2 times 10. Copy the operation plus, and then 3 times x is 3x. 3 times negative 4 is negative 12 actually. So simplify, 1/2 of 6 is 3x plus 1/2 of 10 is 5 plus 3x minus 12. So combine like terms, 3x plus x, this will give us 6x. 5 minus 12 is negative 7. Now we're asked to find the value or evaluate the expression 2x minus 3xy plus 4y when x is equals to 3
and y is equals to negative 5.
So we simply write the original expression 2x minus 3xy plus 4y and replace the variables with a given value. So for x, we will replace it with 3. And for y, we replace it with negative 5. And then we compute. 2 times 3 is 6. Negative, positive, negative will give us a positive. So 3 times 3 is 9, times 5 is 45. And 4 times negative 5 is negative 20. Therefore, what do we have? 6 plus 45 is 51 minus 20, we now have 31. Okay guys, why don't you give a try on this expression? Evaluate x squared minus 4xy plus 3y squared when x is equals to 2.
And y is equals to negative 1.
Pause the video and do this one. Okay, let's do this together. X, we replace it with 2, and then we square. We copy minus 4, x change it with 2, y is negative 1 plus 3 negative 1 square. Okay, simplify. 2 times 2 is 4. Negative, positive, negative will give us positive. 4 times 2 is 8, times 1 is still 8. And 3 times negative 1. Negative 1 times negative 1 is 1. 1 times 3 is still a 3. So 4 plus 8 is 12 plus 3. Finally, we have 15. Did you get it right? Okay, give yourself a pat. I guess you also need reminders on common mistakes. Okay, there are times when we missed or we overlooked little yet very important part of our expression. Take a look at this. When we're asked to evaluate x squared when x is equals to negative 3, it means a negative 3 times negative 3. So negative is included in the squaring. Unlike this one, only the 3 was squared and the negative 3 was left. So this is incorrect. Okay, and this is the correct form. Next, we were asked to evaluate negative x squared when x is also a negative number 3. So when we substitute, we copy the negative sign and then we square the value of x. But what happened? Negative times negative is a positive. Don't forget there's still a negative outside. So this must give us a negative 9 instead. Is it clear? Okay, good. Now it's time to practice. So go ahead, pause this video, get your notebook and pen, and work on your solutions. And when you're done, continue to watch this video to check your answers. So are you done? You ready to check your work? Okay. There you all have the answers. So how was it? Did you score well? Well, that's good. I hope you learned from this video presentation, and I pray that you continue to do your very best. See you in the next lesson video, guys. Bye.